Okay, welcome back. Today's lesson is 4.6, talking about isosceles, equilateral, and right triangles. Isosceles, equilateral, and right triangles. Okay, hopefully you guys all got your assignments done yesterday. I know those were difficult proofs. I know there was a lot of proofs there. Make sure you're working on those if you did not get them done, and they need to be done before I get back. Okay, we will talk about some things when I get back, but your assignments have to be done. Alright, first thing we want to talk about is just some basics of a triangle. Okay, of an isosceles triangle. So I have, we do this in, okay, I have my isosceles triangle here. Okay, the top of it, okay, this right here, okay, this is what we call the vertex angle. Okay, it makes the vertex of the triangle. It's at the top. That is our vertex angle. Okay, our bottom two angles, which are at the base of our triangle, okay, bottom two angles at the base are called base angles. Okay, pretty straightforward and obvious there for you. Base angles. Okay, once again, obviously, the bottom here is called the base, and these are congruent to each other. The isosceles triangle, we've already talked about that. These are our legs. So just a quick diagram there for you. Take a look at the names of the parts of an isosceles triangle. Alright, the next thing we have here is a theorem. It is called the base angles theorem. Base angles theorem. That written down. The base angles theorem says if two sides of a triangle are congruent, then the angles opposite them are congruent. Okay, so if two sides of a triangle are congruent, then the base angles opposite them are congruent. If two sides of a triangle are congruent, then the base angles opposite them are congruent. And actually, you can just say, then the angles opposite them are congruent, is what the book says. It doesn't matter. We're talking about base angles, we can say base angles opposite them are congruent. A diagram to go along with that. It tells me the sides of the triangle are congruent. So it tells me that those are congruent. Okay. So we can say if AB is congruent to AC, then angle B must be congruent to angle C, is what that theorem is telling us. Okay. Now, we also have a base angles converse, which says if the base angles of a triangle are congruent, then the sides opposite them are congruent. Okay? If the base angles of a triangle are congruent, then the sides opposite them are congruent. All right, that might be kind of obvious to you guys, or sound kind of obvious. And once again, the converse, we're just flipping it around. All right, now, let me draw a quick diagram there, and then I'll explain something to you. Okay, it tells us that my angles are congruent. All right, so we can say if angle B is congruent to angle C, then AB must be congruent to AC. Okay. So those should both be on your theorem sheet. Okay, but what I want you to do is on your theorem sheet you should have base angles, and then you should have base angles converse right below it. Okay, go ahead and off to the side, put a little bracket. When you write these as or in your proofs, okay, as theorems, either one of them, it doesn't matter which one it is, you can just say base angles. Okay, so you do not have to distinguish between the base angles theorem and the base angles converse theorem. Okay, you just need to know that these things happen or are because of base angles. Okay, you're either going to know your sides are congruent or you're going to know your angles are congruent. Regardless, you can just say base angles. Okay. We also have next a couple corollaries. All corollaries are rules. Okay, they're definitions, they're rules. Okay, they're telling us something is a fact. Okay, first one, and you cannot put these on your theorem sheets. Okay, these are just going to be things that you need to memorize. They're going to be pretty obvious though. Right, you're not going to have a problem memorizing these. Okay, if the triangle is equilateral, okay, if the triangle is equilateral, then it is equiangular. Okay, remember, equilateral means the sides are the same length. Equiangular means the angles are the same length. So if all the sides are the same, then all the angles have to be the same. Okay, that's one of them. The other one says the exact same thing except backwards. It's a converse. Okay, if the triangle is equiangular, then it is equilateral. Okay, and again, hopefully that's fairly obvious with the fact that if we have this one, we have to have this one. Okay, if it's equilateral, it's equiangular. If it's equiangular, it's equilateral. Okay, using that idea, okay, and what we just talked about with our two new theorems, let's work through a problem here. Okay, so I have this diagram here. Okay, and it tells me, even though it might not look like it, tells me that these three sides are all congruent, that this is x degrees, and this is y degrees. Oh, it also tells me that this side's congruent to those. Okay, I want to find the value, the values of x and y. Okay, we are going to have to find x first. Okay, but take a look at your theorems and your two corollaries you just wrote down and figure out, what do I know since all three of these sides are congruent? Okay, remember that makes your triangle equilateral. Okay, this is an equilateral triangle here. You need to tell me what else we know. When you know the answer to that, raise your hand. If you do not, you need to talk to your neighbor about that. Since I know it's equilateral, what else do I know? We should have came up with the fact that it must be equiangular. Remember those corollaries. If it's equilateral, then it's equiangular. Now, since it's equiangular, we should also know that this measure of this angle is also x degrees. Okay, if it's equiangular, they all have to be the same. So this must be x degrees also. Okay, well, how many degrees are in a triangle? We know that there's 180 degrees in each triangle. Okay, so what should my angles add up to? They should add up to 180 degrees. So I know that x plus x plus x, okay, this angle, that angle, all have to add up to 180 degrees. Okay, now, if that's the case, then that also means that I have 3x equals 180 degrees, okay, which therefore means that x must be 60. Okay, give you a second to think of that on your own there. So I know now that x is 60 degrees. Okay, so I've solved half my problem. I know that x equals 60 degrees. Okay, keep your answers organized. If you're finding two variables, okay, make sure you write them in one place so we can circle them all at once. Alright, we know that x is 60 degrees. Okay, so we're pretty much done with this triangle. Alright, there is a way we can use it still. Alright, but what do I know about this triangle? Okay, notice it does have two legs that are the same, which you should know by now means that it is in what kind of triangle? What kind of triangle is this? Raise your hand if you know the answer to that question. If you do not, you need to talk to your neighbor and figure out what kind of triangle that is. Alright, that is an isosceles triangle. An isosceles triangle. Well, we know if the legs are congruent, then the angles have to be congruent. Okay, that was that first theorem we talked about today. First theorem says if the legs are congruent, then my angles are congruent. So keep in mind that this must be y degrees. Now, does that mean that this angle is y degrees? No, okay, it does not. Only these two angles are congruent. Okay, notice it doesn't even look congruent. It doesn't even look the same as the other two. Okay, don't go telling me that this is y degrees and that's y degrees and so is that when they don't even look the same. Okay, I know I've told you that looks don't really mean much in geometry, okay, but they're not going to screw with you that much. Okay, if it's an acute angle and that's an obtuse angle, all right, they're probably not going to be the same. Now, I want to figure out what the measure of this angle is. Okay, keep in mind, I know what x is. So when you can tell me what the measure of this angle is, raise your hand. If you cannot, you need to be talking to somebody with their hand up. Okay, first you should see that they are a linear pair. Okay, so how am I going to figure out what that other angle equals? All right, we should have noticed that since they are a linear pair, they must add to 180 degrees. Well, if they add to 180 degrees and this is 60, then this angle here must be 120 degrees. All right? Now, if that's 120, okay, and I have these two equal to each other, when I combine these two together, what should they equal? And we should know how many degrees are in a triangle. All right, here's 120 of them. So if there's 120 here, how many is left over for us to divide between those two angles? All right, we know there's 180 degrees minus 120. We should know that between the two of these, there's 60 degrees. All right, hopefully everybody's following that. Between the two of these angles, there's only 60 degrees left, because here's 120 of them. All right, now that means, let's get this out of our way a little bit. That means that y plus y should be equal to 60 degrees. Okay, which also means that 2y equals 60 and that y equals 30. Okay, so now you have solved for x and y. Y equals 30 degrees. And there we have our answer. Okay, I know that can be a difficult process. Okay, work on this. Okay, think about what you know. Use our two new theorems. Okay, use all your algebra skills that I know you guys have. Okay, use that information. Take your time and think through some of these problems. Okay, they are not meant to be easy, and they are meant to challenge you. Okay, now, so far up to this point, we have 4 different ways that we can use to prove that triangles are congruent. Okay, we should have side, 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 angle, side, angle, angle, side, okay, and angle, side, angle. And those are the 4 that we should have to prove triangles are congruent. Now, we're going to add one more right now. Okay, we are going to add to this. This can go on your theorem sheet. Hypotenuse, leg. When you write this in a theorem, you can just put HL. Okay. This theorem says if the hypotenuse and leg of one right triangle, notice it has to be a right triangle, are congruent to the hypotenuse and corresponding leg of another right triangle, then those triangles must be congruent. Okay, I know there's a lot to write there. If the hypotenuse and leg of one right triangle are congruent to the hypotenuse and corresponding leg of another right triangle, then those triangles must be congruent. They have to be congruent. Notice they also have to be right triangles. Excuse me. And if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and corresponding leg of another right triangle, then those triangles must be congruent. A drawing of that and notice they're right triangles. A, B, C, D, E, F. Okay. If BC is congruent to DF and AC is congruent to EF, then triangle ABC is congruent to triangle EDF. Okay. So just another way that we can prove triangles are congruent to each other is using our hypotenuse leg theorem. Okay, now, what I want you guys to do for tomorrow, we need to do page 239, (8 through 25). That is all. All right, and tomorrow you will get an add-on assignment for this. So make sure you have this done for tomorrow, okay? And tomorrow you will add on. Okay? Utilize each other, use your resources, right? Talk to each other, okay? Help each other out. Okay? Have a good day.